On this very first homework assignment of semester 1, it's WSPM, and we're really going to be solving systems using the graphing skills that we talked about today. If we look at this first part of the homework, it says use the graph at the right to determine if each system is consistent or inconsistent, and if it's dependent or independent. So they're not even asking you to solve. They're just saying, is this system right here, is it consistent or is it inconsistent? So if we take a look at the graph over here to the right, y equals x minus 1. Y equals x minus 1 is right here. Y equals x minus 1 is this line right here. That's y equals x minus 1. And then y equals negative x plus 1. If you look for that one, it's right here. Y equals negative x plus 1. It's this one over here. So if you compare this line with this line, they do cross right there at that location. So if they asked us for the answer of those two lines, you would say that the answer is 1, 0, the coordinate 1, 0. But they're not asking for the answers. They're just asking you to classify it. So since you know that they do cross, and they cross at one point only, you would say that it's consistent independent. Now, once again, why do I say it's consistent independent? Because if you look at one line, y equals x minus 1, which is this line right here, and you can look at the other line, y equals negative x plus 1, it's right there. This is where they cross. So that's one answer only. It's an independent, it's consistent independent. Once again, to help you refresh your memory on the vocab, it's right here on the word wall. Again, inconsistent means that there is no answer. Consistent means that there is an answer or infinite amount of answers. So if you say it's consistent, then you got to ask yourself, is it just one answer, which means consistent independent? Or is it an infinite amount of answers, which means consistent dependent? That's when the lines are the same line, which has an infinite amount of answers. So all they're asking you to do on this first part of the homework is to look at the lines that they already graphed for you, and then you just determine if it's consistent dependent, consistent independent, or if they're parallel, you would just say inconsistent, right? Let's just do a couple more of these. Let's look at number 3. Now, number 3, do they give you, I already know that this one's in slope-intercept form. This one's not in slope-intercept form, it's in standard form. And over here, actually, they do give it to you in standard form. So 2x minus 2y equals 2, that's this line. And if you look at the other one, y equals x plus 4, it's this line up here, y equals x plus 4, it's this line. I might as well draw them in a different color so you could see it. So we're talking about y equals x plus 4, that's this line right here. And we're also talking about this one, 2x minus 2y equals 2, which is that one right there. What could he tell me about those blue lines? They're parallel. So if I wanted to classify these, I mean, with these words up here, parallel lines, what's the classification of those parallel lines? It's inconsistent. And that's it. So over here, for number 3, you just write down inconsistent. Now, they're not asking us to solve. If they told us solve number 3, what would our answer be? Our answer would be no solution. But they're not asking us to solve. They're asking us to classify. So right here, it's just inconsistent. Does that make sense? Of course, all of your answers are on the back side of your homework. That's so you can be verifying as you go. Okay. Now down here, number 5, it says, graph each system, determine the number of solutions it has. If it has only one solution, name that solution. So you actually have to graph on every single one of these. So I don't know, which one do you think is challenging so we could do it? Or should we just start like number 5? Pick one. So number 5, is the top one ready to graph? No. So I like to use different colored pens. I want to rewrite the top one I want to subtract 2x, I will have negative y equals negative 2x plus 1. But instead of a negative y, I want a positive y. So I'm going to have to multiply everything by negative 1. And then my equation will become positive y equals positive 2x minus 1. Are you with me? So that top equation becomes y equals 2x minus 1. I wrote it in red on purpose because I want to graph it in red. It crosses at negative 1. And then from that point, my slope is what? 2. In other words, my slope is 2 up 2 over 1. So from this point, I want to go up 1, 2, and I want to go over 1, and I'm going to put a dot right here. Let me do it in red. And then I want to continue to go up 2 over 1, up 2 over 1, and I could go backwards, down 2 over 1 the opposite way, so I could extend it this way. Anyhow, this is my red line. Put some arrows on it because it continues forever. And now let's graph the bottom equation with a different colored pen. If you have one, I'm going with blue. Now this bottom one, if I want to be more comfortable with it, I could rewrite it as y equals 0x. That means there is no slope, minus 3. And now you could think of it as slope-intercept form. It crosses at negative 3, which is right here. Now from that point, how much do I rise? How much do I run? What's my slope? My slope is 0, which means that this line is totally flat. It's not steep at all. It's as steep as the floor, totally flat. So when I look at my red line, which is right here, this red line represents all the answers of the top equation. When I look at my blue line right here, the blue line represents all the answers of the bottom equation. And when I'm trying to find that one answer that works for both, I'm really looking for the point of intersection, which is right here. Now, what is that location? So negative 1, negative 3 is that location. So that's your solution, negative 1, negative 3. That's your answer. Answer. Now, what does it mean that negative 1, negative 3 is your answer? It means that if you plug in x equals negative 1 and plug in y being negative 3, it should give you a true statement on the entire system, on the top and the bottom equation. And if you do, you'll see that it does work, and that's how you double check. Okay, it's really that easy, guys. Should we try number 6? So on number 6, how do we graph x equals 1? That's a weird one because you can't write it in y equals mx plus b. What kind of line is this? Vertical line, up and down. So you go to your x-axis. Here's your x-axis. You go to the x value of 1. You put a dot right there. And it's going to be the line that just goes up and down through that value of x equals 1. That's your line of x equals 1. Of course, you could just come up with a bunch of coordinates that satisfies x equals 1. That means a 1, 1, 1, 1. And over here, you could put whatever you want. Negative 1, 0, 2, 1, whatever you want. And if you see the coordinate 1, negative 1, 1, negative 1, it's right here. 1, 0 is right there. 1, 1 is right there. 1, 2 is right there. You'll see that you get that perfect vertical line. Anyhow, the other one, you still need to modify and get y by itself. This one, you need to get y by itself. So you subtract 2x, subtract 2x. You have y equals negative 2x plus 4. And now you could graph it. What's the b value on that blue equation? 4. So 1, 2, 3, 4. It crosses right here. What do I do from that point? Down how many? 2 and over 1. So down 2 over 1, it's right here. Down 2 over 1, it's right there. And so on and so on. There's my blue line. Put arrows on it. We want the point that they both share. You want the point where they intersect. What is that point of intersection? It's the coordinate what? From the origin. Here's the origin. 1 on the x, 2 on the y. So my answer is 1 on the x, 2 on the y. That's it. If you wanted to be more sure of yourself, you could take the x value of 1 and plug it in right here, and that'll be a true statement. Plug in the x value of 1 right here and the y value of 2 right there. 2 times 1 is 2 plus 2, it really does equal 4. So what we've done right there is double checked both equations. This does work for both. So it's that easy, guys. All you have to do is graph them and find the point of intersection. So let's try 12. 12's interesting. Again, it's a good idea to use different colored pens if you have them. The top equation, I want to get y by itself. So I'm going to subtract x. I'm going to have 2y equals negative x plus 4. And my final step would be to divide by 2, divide by 2, divide by 2. Now notice that there's an invisible 1 in front of the x. So my final slope-intercept form equation for the top one, which I'm going to write in red right here, is going to be y equals negative 1/2 x plus 2. That's my final slope-intercept form equation. And I could easily graph that. Where does it cross the y-axis? Where does it cross the y-axis? 2. Now, you know what? If I look at the other one, I don't even have to graph it. Why not? It's going to be the same line. So what's my answer going to be? It's going to be infinitely many solutions. If you want, you could put IMS, infinitely many solutions. I'm actually going to graph it just for fun. The red one, it crosses at 2. I go down 1 over 2, down 1 over 2, and I could go backwards, up 1 over 2 the opposite direction, and there's my red line. Now, if I look at my blue one, that one also crosses at 2, and it also goes down 1 over 2, down 1 over 2, and so on and so on. So the red and the blue are actually the same exact line. So I'm looking for the point that's in common. I'm looking for the point that's in common, and there's an infinite amount of points in common. That's why we say, what's the answer? The answer is infinitely many solutions. Now, I don't think right here they ask us to classify. Do they? Determine the number of solutions. Yeah, it doesn't say classify. On the back side of the worksheet, does it actually classify it and say that it's a consistent dependent? No, right? Okay, so yeah, we're just looking for the answers. If they ask us to classify, then you would have to say consistent dependent, but they're not saying to classify, they're just saying find the answers. Cool? All right. How about number 13 here? If I were to graph this one, the top one's ready to go. It crosses at 3. From that point, what do?
2.
Up 2 over 1, right? The slope is 2 over 1. So if I go up 2 over 1, I end up right here. And you could go the other way and keep going the other way. And there's your red line. Now, if we look at the bottom equation, let's go with blue ink. Divide by 3, divide by 3, divide by 3. So you're going to get y equals 2x minus 2. So at this point, I already know that they're going to be parallel because I could clearly see that this slope is 2 and this other slope is 2. It's the same slope. They're going to be parallel. Let me graph it anyway, which I don't really have to do anymore because I already know that there is no solution. Crosses at negative 2. From that point, I go up 2 over 1, up 2 over 1, up 2 over 1, and there's my blue line. So if we're looking for where these lines cross, we know that these lines do not cross. They're parallel. So when I'm looking for the answer, what could I say about the answer? There is no answer, no solution. You could also use this symbol. There is no answer to this system. What that really means is that if you take a look at this system as a whole and you try thinking of numbers for x and for y, you're never going to be able to find an answer because they never cross. Okay? So most of the time, you're going to be able to find one answer because they do cross. Or one answer because they do cross. But sometimes, it's rare, but it does happen, they don't cross. That's where you say no solution. Or sometimes, it's rare, but it happens, it's the same exact line. That's when you have infinitely many solutions. Okay? So those are the answers, and don't confuse them with classification. If I ask you to classify, which I do on the first part of this homework, if I ask you to classify, then you have to think about the word wall. That's where you name them when they ask you to classify it. Okay? Consistent independent, one answer. Consistent dependent, infinite answers. Inconsistent, no answers. So they don't ask us to classify this last one. They don't ask us to classify, but let's pretend that I did ask you to classify. What would that be, the last one? Whoa, sorry. Inconsistent. And that's it. And that's what we're doing today, and that's what we're doing tomorrow, and that's going to be a giant part of the quiz Friday. Okay, so if you guys understand this, all you have to do is practice to get a better understanding to start off the semester with an A. Okay, so let's get to work.